We are continuing with notes on solving systems of equations. We have solved them by graphing. We have solved them by substitution. We are going to continue solving by substitution today. A little bit of review as well as a couple problems that turn out just a little bit different. Example 1 here does ask us to solve by substitution, and we are given 20x plus 2y equals 128. That is one of our equations. Y equals 1 minus x is our second equation. To solve by substitution, we are going to take the variable that says that it's equal to something else, in this case y equals 1 minus x, and we're going to substitute 1 minus x in for the y. Those two things are equal to each other, so we're rewriting this top equation, 20x plus 2y equals 128. But instead of y, I'm putting in what y is equal to, which is 1 minus x. We started with two equations and two variables, x and y. I now have one equation with one variable, just x, so we should be able to solve it. We're going to solve by first distributing this positive 2. So I've got 20x, I've got positive 2 times 1, positive 2 times negative x, combine your like terms, 20x minus 2x is 18x, subtract 2 from both sides, and divide both sides by 18. And this one would probably be a calculator problem. Let's go ahead and use your calculators to evaluate 126 divided by 18, giving us x equals 7. To get y, we go back to either one of the equations. The equation that says y equals is going to be the easier one to work with, and we plug 7 in for our x. Y equals 1 minus x, but x is equal to 7. 1 minus 7 is negative 6. We can check our solution by plugging both of these into both equations. Remember, that's the very first thing we did, was check a solution. 1 minus x, 1 minus 7 does give us negative 6. It does work in this one. 20 times x, 20 times 7, that's 140. 2 times y, 2 times negative 6, positive times negative, that's minus. 2 times 6, that's 12. 140 minus 12 does indeed give me 128. It works in both equations. I know our solution is correct. Example 2 looks very similar. 6x minus y equals 20, y equals x plus 5. So I've got a top equation, it's got x and y on the same side, that's called standard form. Second equation, y equals, that's slope-intercept form. We are going to substitute in for y. You have to be careful though. I see a lot of students do it like this. We take x plus 5, we plug it in for y, and we write 6x minus y, which is x plus 5, equals 20. I want you to think for a minute about what could possibly be wrong about what I did there. We want to subtract all of y. Every time I've plugged in, both in the notes last time and in example 1, when we've substituted, we substitute in parentheses. We still need to do that. I need to subtract y, all of y. Y is x plus 5. I need to substitute in parentheses, and you should always substitute into parentheses. So now when I distribute this 1, I've got 6x, I'm distributing at negative 1 minus 1. So we've got negative 1 times x and negative 1 times positive 5. Negative times positive, that's minus 1 times 5. Notice this is very similar to what I had written before, but this had plus, and it should be a minus after I've distributed that negative 1. Now the problem should be very similar to the previous one. 6x minus 1x, that's 5x. Add 5 to both sides. And divide both sides by 5. I don't know what happened there, but we'll go with it. I get x equals 5. Plugging 5 in right here for x, I get y equals 5 plus 5. Pretty sure that's 10. And you should know how to check a solution. There will be times that you'll be required to show your work and how you check it. The very least I would do is check by plugging it in and working in your head here. 5 plus 5, that's equal to y, 10. 6x, 6 times 5, that's 30. Minus y, 30 minus 10 equals 20. Sure does. Example 2, we know our answer is right. X equals 5, y equals 10. Again, you can write your answer like this, or a lot of times you'll see it written as an ordered pair. Either should be acceptable. Example 3, solve by substitution. This one's a little bit different in that both of our equations say y equals this time. We've got y equals 7x minus 5 and y equals negative 2x plus 4. Y equals 7x minus 5, y equals negative 2x plus 4. Start by substituting. In this one, I have y equals and then I have y equals. So it doesn't matter which one you start with. I'm going to start with the top one here. Y is equal to 7x minus 5. So I'm going to take 7x minus 5 and I am going to plug it in for the y. You could have taken negative 2x plus 4 and plugged it in for this y. You would get the same answer. So I'm taking 7x minus 5, I'm plugging it in for y. So I get 7x minus 5 equals negative 2x plus 4. I just said on the last problem, anytime we substitute in parentheses. So yes, I'd be in the habit of putting this in parentheses here. Notice I just have a positive 1, so distributing a 1. 1 times 7x, 1 times negative 5. This time it actually did not matter if I had those parentheses or not. I would be in the habit of anytime you substitute in the parentheses. I don't have any like terms. At least no like terms on the same side. This minus 2x and 7x, yes, those are like terms, but my equal sign's right there. Those are on different sides of my equal sign. I cannot combine them. When that's the case, move all the x's over to the same side. We do that by adding 2x to both sides. 7x and 2x is 9x. And we're down to a two-step equation, which we should know how to solve. Add 5. And divide both sides by 9. X is equal to 1. That is my x value. Don't forget to get your y value. We can get our y value by plugging 1 into either equation. Doesn't matter which one. I'm going with the top one. Y equals 7 times 1 minus 5. 7 times 1 is 7. 7 minus 5, I get y equals 2. Notice, had you chose to plug it into the bottom one, we would get y equals negative 2 times 1 plus 4. Negative 2 plus 4, that's also 2. You get the same answer no matter which one you plug it into. Example 4. Example 4, we've got a equals 9b minus 4, and 2a minus 18b equals 16. A equals 9b minus 4, and 2a minus 18b equals 16. Start by substituting. A equals, so I know a and 9b minus 4 are the same thing. So I can replace a with 9b minus 4. So I'm recopying the bottom equation, 2 times a, but instead of a, I'm putting in 9b minus 4. Now I've got minus 18b equals 16. I copied this equation exactly as it is, but instead of a, I put in 9b minus 4, and I put it in parentheses. Now we distribute. 2 times 9b, 2 times negative 4, minus 18b equals 16. And as I mentioned earlier, these problems turn out a little bit different this time. This doesn't happen often, but notice 18b minus 18b. I don't have any b's left. Those cancel out. I just get negative 8 equals 16. Negative 8 equals 16. Well, they're not equal to each other. When that's the case, we have no solution. Remember when we solved by graphing, sometimes we got no solution, and that happened when I had parallel lines. If I were to graph these two, we would wind up with parallel lines. No solution is correct. Remember also, sometimes we had it, so I can't graph just one of those, but instead of no solution, we graphed one line and it looked like that, and then we graphed another line and it looked exactly the same, and we said infinitely many solutions. Let's take a look at one where we solve by substitution and we end up with infinitely many solutions. So y equals 6x minus 4 and 12x minus 2y equals 8. Y equals 6x minus 4, 12x minus 2y equals 8. Start with your substitution. Y equals 6x minus 4. That's your first step. That goes in for my y. $12x minus 2 times y, but I'm putting 6x minus 4 in for y equals 8. Distribute. Negative 2 times 6x. Negative 2 times negative 4. Negative times negative, that's positive. 2 times 4 is 8. 12x minus 12x. Again, 12x minus 12x, I don't have any x's. I just have positive 8. 8 equals 8. 8's always equal to 8. So there are, any x value would work here. We have an infinite number of solutions. We say that there are infinitely many solutions. That's our last example problem, example 6. And again, it looks a little bit different. We're still solving by substitution. And we have 3x plus y equals 9 and 4x minus 2y equals 2. 3x plus y equals 9, 4x minus 2y equals 2. Notice this one's different in that none of the equations, neither one of them say x equals or y equals. They're both in standard form. We have x and y on the same side of the equal sign in both equations. When that is the case, we want to choose one of the variables in one of the equations and solve for it. So I either need to solve for x in this equation or y in this equation, or I could solve for x in this equation or y in this equation. It is by far going to be easiest if you solve for a variable that has a coefficient of 1 or negative 1, but 1 is the easiest. Notice here I have plus 1y. So we're going to take this equation, I'm going to rewrite it over here, and we're going to solve for y. We solve for y by subtracting 3x from both sides. So we get y equals 9 minus 3x. You could write it as negative 3x plus 9, or I'm just going to leave it as 9 minus 3x. So this equation and this one are the same thing. I just rewrote it so that it says y equals. And the reason we did that was so that we can now take 9 minus 3x and we can substitute it in for the y. We are taking that and we are plugging it into the other equation, not the one it came from, but into the other equation for the y. 4x minus 2y equals 2, but y is equal to 9 minus 3x. We solved for y so that we could then substitute. And now this equation looks almost exactly like any of the other. It's 4x, distribute, minus 18, negative times negative, that's positive. Combine up your like terms. Add 18. Divide by 10. And I know I'm flying through this. We've done this part a bunch. This is the new stuff up here in blue. Once we get x equals 2, you go back to any equation and plug in 2 for x. 3 times 2 plus y equals 9. I get y equals 3. So continuing with systems by substitution today. Problems that might look a little bit different. A couple things that we have to do that are a little bit different, but same overall method.